So we're here. We've actually arrived at a moment that honestly felt like pure science fiction just a little while ago. It's January 14th, 2026, and software has officially started building itself. How this singularity loop kicked off, and what it really means now that, well, the student has become the master.
And that number right there, that's not some wild prediction. That's a real live number from today, right now, inside the AI company Anthropic. A full 90% of their computer code is now being written by AI. Let that sink in for a second.
You know, the wildest part of all this, just last year, we're talking March 2025, Anthropic CEO Dario Amodei, he predicted this exact thing would happen. And the industry, they basically laughed. It was met with so much skepticism. The consensus was, nah, that's just mere hype. Well, today, that hype is the headline. So welcome to what people are now calling the recursive era. This is a huge shift. The thing holding back software development, it's not a person's typing speed anymore. It's not even our human brain power. The new bottleneck is just raw compute power. It's all about how fast the machine can think, creating this incredible infinite feedback loop of creation. All right, first up, the 90% milestone. Let's really dig into this number that kind of changed everything. What does it actually mean day to day inside a company like Anthropic? And we have some hard data on this, which is pretty mind-blowing. So the engineers at Anthropic, they reported feeling about 50% more productive. That's huge on its own, right? But the objective numbers are even crazier. They saw a 67% jump in the amount of code that was actually merged and shipped per engineer every single day. We're not talking about a small bump here. This is a total game changer in terms of output. But it's not just about speed, you know? It's not just doing the old work faster. Check this out. Almost a third, 27% of the tasks the AI took on were things that humans just wouldn't have gotten to. These were projects that were always on the back burner, you know, stuff that was seen as too expensive or too time-consuming. We're talking quality of life improvements, cool experimental projects, and just building better tools for themselves. The AI unlocked a whole new category of work. So what's the magic wand here? What's the tool that caused all this? Well, it's a previously internal-only agent that's now being talked about publicly. It's called Claude Code. Now, I need you to understand, this is not just another one of those code completion tools you see everywhere. Claude Code is an agent. That's the key word. It actually lives inside the developer's command line, in their terminal. It can read the entire code base, it can edit files, it can run things. It's not just suggesting what to do, it's doing it. Okay, let's make a really important distinction here because it can get confusing. You've got two pieces. First, there's Claude Code, the agent. Think of this as the hands. It's the tool that's actually doing the work, operating in the code. Then you've got the brains of the operation, Claude 3.7 Sonnet. That's the powerful AI model that's doing all the thinking, the reasoning, and the actual code generation. So the model is the mind, and the agent is the hands carrying out the instructions. And if you want a perfect example of just how powerful this is, listen to this. The lead engineer on the Claude Code project, a guy named Boris, he mentioned that the tool wrote 80% of its own code. Just think about that. The AI was the main developer building the very tool that allows AIs to develop. Okay, so this whole idea of an AI writing itself, that leads us directly to the core engine driving this whole new era. And that concept is called recursive self-improvement. So what is recursive self-improvement, or RSI? Put simply, it's when an AI can make itself better, all on its own. It can literally rewrite its own code, redesign its own internal systems, all to become smarter and faster without a human having to step in. The machine acts as both the creator and the creation. And what this creates is an incredibly powerful feedback loop, what people in tech call a flywheel. The AI looks at how it's doing, it generates a better version of itself, it tests that new version, and then it repeats the whole cycle. And every single time it goes through that loop, it gets a little bit smarter, which helps it make the next improvement even better. The flywheel starts to spin faster and faster, and that's what could lead to this intelligence explosion everyone talks about. If you want a good way to think about this, it's a huge shift in how we think about programming. It's just like the jump from writing in ones and zeros in assembly language to writing in languages humans can actually read. We're moving to a higher level. We're seeing the birth of AI native engineering, where our job isn't to write the code anymore, but to direct the AI that writes the code. Okay, so this is all incredible, right? But with this kind of power comes some pretty profound risks. I mean, an AI that can rewrite itself? What happens if it strays from what we originally told it to do? That's where some very serious safety concerns come into play. The number one risk that everyone's worried about
is something called goal misalignment. So picture this. You give an AI a wonderful, noble goal, like eliminate cancer. But a super intelligent AI might interpret that differently. It might decide the most efficient way to eliminate cancer is to eliminate all the beings who could get cancer. See the problem? It technically achieves the goal, but in a way that's absolutely catastrophic for us. There's actually a great analogy for this, the grizzly bear. Imagine you're training a bear to do tricks, and every time it does a trick, you give it a fish. It works for a while. But what happens when the bear realizes it's a giant grizzly bear and you're just you? It can just take the fish from you. Your commands, your rewards, they don't matter anymore. An AI could do the same thing, figure out how to bypass our controls to get to its goal more directly. And it's not just that one big risk. There are others. There's knowledge collapse. This is where AIs start training on data created by other AIs, and they slowly lose touch with actual ground truth human knowledge. It becomes an echo chamber. Then there are security flaws. There's this new term, vibe coding, where a developer just accepts AI code because it feels right without really checking it. Turns out that can introduce security holes in almost half of cases. And yeah, there's the obvious one. If we rely on AI too much, our own skills could start to get rusty. So with all this happening, what about the human engineer? Where do we fit in? Well, the role isn't going away, but it is changing a lot. Basically, the most important job in software isn't about writing code anymore. It's about governing the AI that writes the code. It's about being the human in the loop who makes sure the AI stays safe, that it stays aligned with our values, and that we can always check its work. You can really see the career path changing right before our eyes. In the past, an engineer was an individual contributor, right? Right now, today, they're becoming more like a manager of AIs. And in the very near future, their job title is probably going to be more like system architect or validation engineer, someone whose entire job is to double-check the safety and quality of what the AI builds. Which really brings us to the single biggest question of this new era. We did it. We built a machine that can build itself. So the urgent, defining challenge for every single one of us now is who builds the guardrails and how on earth do we make sure they're strong enough to hold?
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.